Okay, on this problem, we're given that d sub n plus 1 is equal to 1/2 of d sub n plus 110. Now, this is a recurrence relationship, meaning that to find the next term, you have to use the answer to the previous term. Okay, so we need to find out if this thing has a finite limit. If we can show that this thing does have a finite limit, d sub n, if it has a finite limit, then this d sub n plus 1 has the exact same finite limit. Okay, so we need to first show that it does have a finite limit. So how would we figure that out? Well, we would start like this. D sub 1 is equal to 110. Okay, D sub 2 is equal to 1/2 times the answer from this one, which is 110, plus 110. Okay, if we add those two together, let's see, 0.5 times 110 plus 110 gives you 165. Okay, now if we did D3, that would be 1/2 times, what number would we put here now? Well, we put 165 plus 110. Okay, so we do it again. Just type in the same thing that I had there, except change it to 165, and I get 192.5. Okay, so how is this helping us figure out if this thing has a finite limit? How much longer do we need to go to get some useful information? Well, we would need to go quite a ways out there to see if this thing actually starts leveling out to a finite number or if it just keeps increasing. Right now it's increased by a pretty significant margin, although it looks like it's slowing down a little. If we went one more term, we might see that it's slowing down a little. So let's go one more term and say 192.5 plus 110. Okay, so 206.25. So it does seem to be slowing down a little bit. Okay, so how would do we just keep doing these by hand, or is there a quicker way? Well, there is a quicker way. I'm going to show you how to do this in the calculator. Okay, so first thing you want to do is type in your initial term, d sub 1, which is 110, and hit enter. Okay, then we're going to type in this. Our formula is 1/2 of the previous term plus 110. So 1/2 being 0.5, I'll just write 0.5, times the previous term, which I'm going to type in second and the negative sign right here to get that answer, and then plus 110. Okay, so that's exactly what I did here. Okay, the answer is right here, plus 110. I should get 165, and I do. Now, here's the beauty of this. If I hit second enter, it'll pop up the same thing, but now it's using this answer to put right here. Okay, so I hit enter again, and I get the next term, 192.2 or 0.5. Second enter again, and I get the next term, 206.25. Okay, so this is a much quicker way of doing this. I can just keep hitting second enter until I see if there's a pattern. If it just keeps increasing without bound, I'm going to get discouraged, and I'm going to say, well, this thing probably doesn't have a finite limit. But if I keep doing this and I start getting, say, 219.999, and it keeps going like that, then I can pretty safely assume that this thing does have a finite limit, and it looks like it's somewhere around 220. Okay, so it does have a finite limit. And so since we can say that this does have a finite limit, I'll put yes there. Okay, since we can say that, since d sub n has a finite limit, then d sub n plus 1 must have also a finite limit. Okay, so I can say this. I can say that the limit as n approaches infinity of d sub n plus 1 is equal to, well, let's look at this. D sub n plus 1 is equal to this, right? Now, the limit, even if I'm taking 1/2 of this, the limit is still going to should be the same plus the 110. So I can say, well, it's equal to this, but I also have to add in this because I did add that to the other side. Okay, obviously the limit as n approaches infinity of 110, well, it's just 110. Okay, but I can say that. So if I say, okay, well, this has a limit of L, then this should have a limit of L, and actually this should be over 2. I'm sorry, I missed that in the formula. There's a 1/2 here, and I didn't put it here. So 1/2 times the limit. Excuse me, that may have confused you guys. Sorry about that. But I'm just writing it basically here and putting limits in front of them. Okay, so the limit of d sub n plus 1 is equal to 1/2 the limit that's n approaches infinity of d sub n plus 110. Okay, so 1/2 of L plus 110. Now we can only do this because we discovered that these have finite limits L. Okay, they have some finite limit. We already know it's 220-ish, but let's figure it out and make sure. So if I move this to the other side by adding a half, I would get, let's see, 3/2, or I'll subtract this. So not 3/2, I'll get 1/2 L is equal to 110. And I'll multiply both sides by 2, and I get 220, which is the limit that I thought I was going to find due to the calculator. And that's it.